All objects falling due to the force of gravity accelerate at a constant rate of 9.8 meter per second squared. As long as friction is negligible, mass has very small effects on how an object falls. Once the object drops, it moves in an entirely predictable way. Its position and velocity at every moment in time can be calculated using a small number of equations. In this presentation, you will learn how to solve free fall equation problems. The acceleration due to gravity is a vector, so it has magnitude and direction. It has the same direction at a force of gravity down. When an object is dropped, we make the direction down positive. So the acceleration due to gravity is positive 9.8 meters per second squared. Furthermore, when an object is dropped, the initial velocity is 0 meter per second. If we have a free fall problem where the object is ascending, it's useful to make the direction down negative, which makes the acceleration due to gravity negative 9.8 meter per second squared. Now, we are to apply what you've learned by solving some free fall word problem. A coin is dropped in a vacuum tube. Find its displacement after 0.30 seconds. The first step to solving this problem is to read and underline all the important information or terms and number that will help you to find the unknown. As you will see in the next slide, the word drop give us two important pieces of information. It is also important to underline the unknown. The unknown is the motion of variable you're trying to find. In this case, it is the coin displacement. Step 2 is to turn all your information into variable. Since the object is dropped, the initial velocity is 0 and the acceleration is positive 9.8 meters per second squared. We are looking for the displacement, so we write d equals to question mark, and we were told that the time is 0.30 seconds. Once we have all four variables, we slowly scan and reference table until we find the equation that has all three variables that we have and the one variable that we want. This is the fourth equation. Notice that we substitute our data into the equation with units. After that, we answered with units. Example 2. A coin is dropped in a vacuum tube. Find the coin velocity after 0.30 seconds. Step 1 is to underline the important terms and numbers. Step 2 is to turn our info into variables. Step 3 is to find the equation that fits your four variables and the equation that fits start with a known, but that not always the case. This is substitution with units when you accelerate at a rate of positive 9.8 meters per second squared, and just 0.3 seconds you will only reach the velocity of 2.9 meter per second down. Example 3. A rocket is fired vertically upward with an initial velocity of 29 meters per second. Find the rocket's maximum altitude. The last two problems we did involve an object drop, but this one involves an object sent upward. Whenever you see the problem mentioned as object reaching its maximum altitude or peak, you know that its final velocity equals 0. Since the rocket moves upward, we make the directions down negative, so the acceleration due to gravity is negative 9.8 meters per second squared. Once we have insulated our data and unknown, we scan the equation less on our reference table until we find the equation that has all four of our variables. Here is substitution with units and answer with units, and rockets will travel 43 meters. Example 4. An object dropped on planet X falls 64 meters in 4 seconds. Find the acceleration due to gravity on planet X. Step 1 is to underline all the important words and numbers that will help us find an equation. Since we see the word drop, we knew that the initial velocity is 0. When we scan the equation sheet to find out that matches the 4 variable that we have, we see the fourth equation fits. Notice that it doesn't begin with a known, which is acceleration. Don't let that throw you off. The equation doesn't have to start with a known variable. Here is the substitution with units to find the acceleration. In the last step, we must divide both sides of the equation by 8 to isolate the unknown. When solving freefall problems, remember that when an object is dropped, an initial velocity equals 0 and the acceleration is positive 9.8 meter per second squared. When an object is ascending, the peak velocity equals 0 and the acceleration is negative 9.8 meters per second squared. This is end of my presentation on solving freefall's problem.